Hello, in this video I will go over how to graph a quadratic function in vertex form by finding a vertex, y-intercept, x-intercept, axis symmetry, and I'll also go over a discriminant rule. So yeah, we're graphing a quadratic function in vertex form, and just like I said before, in order to graph a quadratic, you need these things: vertex, y-intercept, x-intercept, if possible. That's related to discriminant rule, axis symmetry, domain, and range. Okay, so discriminant rule just that determines how many x-intercepts you have, or if you have any at all. So the rule states if it's b squared minus 4ac, you have one x-intercept. I mean, so if you do b squared minus 4ac and you get an outcome of 0, that means you have one x-intercept. If you do b squared minus 4ac and your outcome is greater than 0, that means you have two x-intercepts. If you do b squared minus 4ac and your outcome is a negative number or less than 0, you have none. So what is it? It really just discriminant really does save times with factoring, because uh you know how to factor and you don't want to waste your time figuring out, oh no, it's your zeros are imaginary, right? So let's do an example. So an example says, how many x-intercepts does this quadratic function have? So let's figure out our a, b, and c. So our a value is 1. By the way, this is a quadratic in standard form, not vertex form. So our a is 1 because it's the coefficient of the highest power. Our b is -3, and my c is -5, right? So they say do b squared minus 4ac. So that's -3 squared minus 4 times a, which is 1, and c is -5. -3 squared is 9. -4 times -5 is positive 20, and that is 29, which is greater than 0, right? And the rule states if it's greater than 0, you have exactly two x-intercepts. Now, how do you find these two x-intercepts? You pretty much set y to 0 and use your factoring rules. And as you can see, you can't do simple factoring, so you'll probably have to do quadratic formula. But eventually you'll find it and you'll have two x-intercepts. Okay. I'm not going to solve for the x-intercept. I just want you to prove that. I just wanted to show you that there's exactly two x-intercepts because of the discriminant rule. Okay. Okay, so I guess we can start graphing. So let's graph example 1. The quadratic is in vertex form. Graph completely, find vertex, y-intercept, x-intercept, if possible, axis symmetry, domain, range, and find the interval where the graph is increasing and decreasing. So 1 second, let me get this. Okay, so let's first find our vertex. The vertex is actually easy to find, right? It's because it is in vertex form, it's pretty much your horizontal shift and your vertical shift, right? So what is our horizontal shift? It's related to the inside parentheses, or related to this x. It says it's x plus 5. So what that means is shifting it 5 units to the left, not right, because remember, horizontal shift is always the opposite. So this is -5. And then your y coordinate of your vertex is your vertical shift, which is -6. right? You do not change this. With the vertical shift, you don't change the sign, so that's why it's -6. Okay, so yeah, vertex is just horizontal shift, comma, vertical shift, or H, comma, K. Now, once you have your vertex, the axis symmetry is very easy to find. So AOS means axis symmetry. And you do have to write out as an equation. So what I mean is you do have to say X equals. If you just say a number, it will be wrong. So the axis symmetry is pretty much your X value of your vertex. So in our case, our X value of the vertex is -5. Okay, good. Now let's figure out what's the next thing we need to graph a quadratic. I would find the y-intercept because it's pretty much easier to find. So how do you find the y-intercept? You simply plug in 0 into the function. So y of 0 is 0 plus 5 square minus 6. 0 plus 5 is 5 square minus 6, which is 25 minus 6 is 19. So our y-intercept is 0, 19. Okay. Now what's the next one? We got to find the x-intercept. So how do you find the x-intercept? You set y to 0. Now x plus 5, I'm going to have to FOIL that out. X plus 5 is the same thing as x plus 5 times x plus 5. You could do it the long way, factor it, collect by terms, but I'm going to do the shortcut. I'm just going to do a squared plus 2ab plus b squared. Okay, so it's going to be x squared plus 2 times ab. So that would be 10x. And then b squared is 25. This is related to the factoring, so I'm not going to go over the factoring rules. And then you have -6. So that's x squared plus 10x. And then 25 minus 6 is 19. Okay. Now, to save us time, I'm going to figure out if we actually have x-intercepts, because just looking at it, it doesn't look like we could factor it nicely. So it could be imaginary, it could be real. I'm not sure. So we'll just do the discriminant rule. So b squared minus 4ac. So my a is 1, my b is 10, and my c is 19. So b squared is 10 squared minus 4 times ac. So that's 1 times 19. So that is 100 minus 76, which is 24. So if it's greater than 0, we have 2 x-intercepts. Now let's find our 2 x-intercepts by, well, we can't factor this, obviously. It's two numbers don't multiply 19, and that will add up to 10 is nearly impossible, right? So if you can't factor it, what's the last resort? Quadratic formula. So if our a is 1, if our b is 10, and our c is 19. So quadratic formula is x equals opposite of b, which is -10, plus or minus root. B squared is 100, right? I kind of did that in my head. If b is 10, b squared is 100, minus 4 times a, which is 1, and c is 19. I am not going to do that in my head. All over 2 times 1. So that's -10 plus or minus. -4 times 19 is -76. So 100 minus 76 is 24. All over 2. Now I actually need a number, so I don't want to simplify the square root of 24. I needed an actual number, so I'm just going to put this in the calculator. So one of my first zeros is -10 plus square root of 24 all over 2. And Put that in the calculator and you should get negative 2.55. So really it's just negative 2.6, correct? And your other one would be negative 10 minus square root of 24 all over 2. I get negative 7.4. Okay, so your two x-intercepts are negative 2.6 comma negative 2, if you want to write it as a coordinate, negative 2.6 comma 0, and then the other one is negative 7.4 comma 0. Okay, so you have your two x-intercepts, your y-intercept, your vertex, and your axis symmetry. So let's start graphing. So negative 5 comma negative 6 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's negative 5, and then go down 6. 1, 2, 3, 4, 5, 6. Okay, that's your vertex. Our y-intercept is 0, 19. So let's pretend, because our graph is going to be on a scale, let's pretend this is 19 right here. Okay, and then let's plot our two x-intercepts. So one of mine is negative 2.6. Here's negative 2. Negative 2.6 would be right about here. Negative 7.4 is 1, 2, 3, 4, 5, 6, 7. Here's negative 7. So negative 7.4 would be right about here. Connect the dots. Okay, there's your graph. And then one more thing. If you want to draw the axis symmetry, our axis symmetry is x equals negative 5. So what that would look like, it's a vertical asymptote at x equals negative 5. So it's going to look like a dashed line like this at x equals negative 5. Okay, so did we find everything? We found the vertex, we found the y-intercept, we found the x-intercept, axis symmetry, domain, and range. So we haven't found the domain and range and the intervals where it's increasing, decreasing. So let's do that real quick. So the domain, it doesn't matter if it's concave up or concave down. It's going to always be all real numbers. So you can just say negative infinity to positive infinity. The range is all the y values. So what we do is we write it from smallest y value to largest. So it's related to your vertex. So your vertex is negative 5 comma negative 6. And our smallest y value looks like it's at negative 6. So we're going to, for some reason, they include your y value. So instead of using a parentheses, they use a bracket. So it's going to be in negative 6 included. And then it just shoots up to infinity, right? Our y value just shoots up. It just keeps on going to infinity. So it's infinity. And then with infinities, you always put parentheses. Okay, so that's your domain, that's your range. And then where is the graph increasing and decreasing? So your teacher may ask you this. So it's good to know. So when they ask you for increasing or decreasing, they only mean the x values. They don't care about the y values. Yeah. So when you're going downhill, so in this case, this part here, downhill, you're technically going downhill, so that means you're decreasing. So this is decreasing. And then when you're going uphill, I guess this would be considered going uphill, right? So you're going plus, that means that's increasing. Okay. So increasing, we start from the x value of negative 5, that's our vertex. So it's going to be parentheses -5, and then it just shoots up to infinity. Okay, so these are all x values, no y values. And then decreasing, so it's just decreasing. So we go from smallest x value to largest x value. So our smallest x value just says it's going to the left, so it's going to be from -infinity. And then it stops at the x value -5. Okay. Okay, go ahead and if you need to pause the video, go ahead, and I will do example 2 in the next video. Yeah, I don't want to make these videos too long, so I'm gonna do example 2 in another video. Okay, thank you. Bye-bye.